Assalamu alaikum wa rahmatullahi wa barakatuh. You are welcome to physics class today, and the topic for discussion today is motion and forces. And at the end of this discussion, we are going to be able to understand the following points. One, we are going to be able to describe motion of the body and identify forces as causes of motion. Then we are going to be able to state some types of motion with their respective examples, and equally look at forces and types of forces and their examples. Right, let's go into the discussion fully. What is a motion? A body is said to be in motion when it has changed its position with time. So a motion of a body can be defined as the change in position of a body with time, or is a rate of change in position of a body. And the motion of a body can be caused by a force. So force is usually the cause of motion of the body. So the force is going to be discussed later fully. Now we should know that under this we can classify the study of motion and forces into dynamics and kinematics. What is dynamic? Dynamic is simply describing the motion of the body with reference to the force that causes the motion. That is what dynamic is. The other aspect is kinematics, and this is when the motion of the body is described with no reference to the force that caused the motion. Alright, so these are the two classes of motion and forces: dynamics and kinematics. Now going to the second agenda, which is to look at the types of motion. We have various types of motion. We are going to discuss a few of them here. One, we look at random motion. A random motion is a motion that has no specific direction. It's from the term random. When there is no specific direction, when the motion of the body is disarrayed, is zigzag, is disorganized, then such motion is classified under random motion. And number one example here is movement of football players on the pitch. The movement of the ball itself is a random motion because there is no specific direction for the motion of both ball and players. Now another example is Brownian motion, and another one is motion of boiling water. When water is boiling, you have something like this. So it's also classified under random motion. So few examples I'm going to mention are motion of gaseous particles. Under here, we can equally discuss motion of smoke particles, motion of dust particles. There are more examples of random motion. We have Brownian motion, and then we have flying butterfly. A butterfly in flight has no specific direction, it goes zigzagly. So these are examples of random motion, and with random motion, no specific direction. Another example that we are going to look at is translational motion or rectilinear motion. This is simply a motion on a straight line. So if we look at the motion of a car, look at this motion very well. There are two parts of it. You have one that is linear and curvilinear. At the point it negotiates a bend, you can see this curvilinear. This is linear, and this is curvilinear. You can see they are both under translational motion. So the simple definition is motion on a straight line, and we have another one, a chart going in a straight line. This is linear motion. So few examples I'm going to mention here are motion of a car in a straight line, then athletes running 100-meter race in a straight line, and a pen rolling down the table in a straight line are examples. Then another type of motion we are going to look at here are rotational motion and circular motion. These two motions are not the same. Rotational motion is quite different from circular motion. Rotational motion is when a body is moving about its center. When the body is moving about the center, we call it rotational motion. But circular motion is when the body is moving along a circumference. For example, if you look at the motion of the earth can be spinning at a point. When the earth is spinning at a point, it is undergoing rotational motion. But when the earth is when an earth, is moving around the sun, we have circular motion. So let's look at some pictures there. You can see an earth spinning at a point. Spinning at a point is rotational, but when it's going around the sun, it's circular. At every point there is spinning. There is spinning at that point. At this point there is spinning, rotational. At this point there is spinning, rotational. At this point there is spinning, rotational. It's taking rotation at every point there. But as it goes around the sun, it has become circular motion. So there are two types of motion experienced by an earth moving around the sun. We have rotational motion and circular motion. So this is bringing me to a point that the motion of a body can consist of more than one type of motion. You get it? So we should understand that, just like we have seen an earth rotating the sun, it's undergoing rotational motion. It is undergoing rotational motion and circular motion. Okay, another example we have here is, look at a wheel moving about its axis. So it's a rotational motion. And look at this one, the wheel itself is rotating, but a sticky man around the wheel is undergoing rotational motion, because a motion along the circumference of a circle is circular motion. A sticky man around the wheel is undergoing circular motion, while the wheel itself is undergoing rotational motion. So few examples of rotational motion I'm going to mention here are: one, talking about rotational motion, we have cricket ball spinning about its center. We have the earth rotating or spinning around its center on axle. We have rotating wheels of a moving car. And finally, we have rotation of the electric ceiling fan. Now, going to circular motion, few examples I'm going to mention. One, a satellite moving around the earth. Then we have the earth moving around the sun, and we have the planets generally moving around the sun. So we should be able to draw the line between rotational motion and circular motion. Rotational motion move about its center, circular and from a fixed point. Circular motion move along the circumference of the circle. Okay, the last motion I'm going to talk about is oscillatory or vibrational or periodic motion. These three names are equivalent, and this is a motion of a body that repeats itself periodically. It's a to and fro motion of a body. Let's look at few examples. Look at seesaw, to, fro, the motion that repeats itself periodically. Another one is swing, a motion of a swing. You can see it's going to, fro. So this is to, fro is an example of oscillatory motion. Another example is pendulum clock. You can see the pendulum clock is undergoing oscillatory motion. So few examples I'm going to mention are the ones I've stated already: motion of simple pendulum, motion of seesaw, motion of a diving board. Here is a good example. And the final one is motion of a jiggle pair. When you jiggle a pair, the motion, the to-fro motion of that jiggling pair is oscillatory or vibrational or periodic motion. Right, now we have discussed motion, look at types and examples, and we already learned that the motion of the body is caused by force. So what is a force? A force can be defined as an agent that can change the position of the body, either at rest or in uniform motion in a straight line. Then mathematical definition of a force can be: a force can be defined as the product of mass and acceleration. So mathematically, you have force to be equals to mass times acceleration, and that equals to ma. The SI unit of a force is Newton, if you know this, or kilogram meter per second square. That is the equivalent of Newton. Alright, let's look at classes of force, and this is going to be the last point of discussion. Classes of force. We can classify force into two. We have contact force. This is a force that is in between two surfaces in contact. Okay, when the force is in contact with the body it affects, you have that to be a contact force. Few examples are push, pull, tension, normal reaction, weight, air resistance, friction, and thrust. Then we have non-contact force, also known as force field, and this is a force, or these are forces that exist between two surfaces that are not in contact. And we have few examples. We have the prominent examples here are electric force, magnetic force, and gravitational force. I think we have been able to do justice to the lesson agenda, which is to define, which is to describe motion, look at the causes of motion, that is force, look at types of motion, we look at linear motion, we look at translational motion, random motion, rotational motion, circular motion, vibrational motion, and look at forces, classes of forces, contact and non-contact forces, and we have looked at examples. Thanks for your time. Bye bye.